Hi everyone, in this video I will introduce a very important concept in Gio. We will talk about layouts. Layouts are used extensively to arrange widgets like buttons, text labels, and so on the window. Remember, we already saw layout in the previous video to draw a label with this command, material.label the parameters.layout. I need to attract your attention to something important. There is a layout with lowercase l, which is different from layout with uppercase L. Layout with uppercase L is used to render widgets, as we saw in the previous video to render the text label, for example. Layout with lowercase is a helper to lay out and arrange widgets, and this is what we will see today. Today we will see three layout helpers: Flex, Rigid, and Flexed. Layout.Flex, we can see it as a container to hold children like Rigid and Flexed. Layout.Flex has a possibility to arrange children horizontally or vertically. Layout.Rigid is a placeholder to hold widgets that keep their natural sizes. Layout.Flexed is also a placeholder for widgets that occupy the remaining space in Flex. A child can itself hold children. This is a powerful concept that allows to design elaborate interfaces, and you will see it when we start coding. This animation will explain the difference between these three layouts and how they interact between themselves. We have a flex structure that's set to store its children vertically. The first rigid structure will have a widget inside. As we said, Rigid will make the widget inside of it keeps its natural size. The second rigid structure will have the same behavior and will take its natural space right after the first rigid. Now we have a flexed structure which by nature will take up the whole remaining space. Later we have another rigid. This one will push the flexed structure to make enough space for itself. And since the flexed is flexible, it will be resized down to make room for the third rigid. We will see it better once we switch to coding, so stick around, there will be more and interesting examples ahead. Same as we did last time, I will create a folder for this video. I will copy the code of the previous video and work on it for this one. Remember, we built simple window last time and displayed the hello message on it. I will change the title of the window to video 2 layout intro. We don't need to size the window to full screen. We will keep it to default size. I will keep the label as I will use it shortly. Layout.Flex. Notice that the layout is not recognizable. Once I save the file, Visual Studio will import gioui.org/layout. Flex is struct, so I should use curly here. Access layout.horizontal. Close the curly. There are other parameters for Flex. I will plan to talk about them in coming videos. .layout, uppercase L here, to tell Gio to render the flexed children. We provide GTX of type layout.context, and then we will add the children. The first child we will add is Rigid, which has a fixed size. Rigid function accepts as argument an anonymous function func that itself accepts GTX of type layout.context and returns layout.dimensions. Let's check out these two types. On the Go Discover Packages page, search Gio UI and open Layout page. I will add this link to the description below. We expand types and open Type Context. Notice that this type struct has constraints that holds min and max. Layout.context holds the minimum and maximum size of a widget, while dimensions hold the current size of the widget. In another word, the parent, which is Rigid, set constraints struct or sets how large or small the widget should be, and the child, which is the widget inside the rigid, responds with its own dimensions, which is the actual size of the widget. You can read more on this topic on this page. The definitions there are very good. I will add its link in the description below. And the more you exercise by using the layouts, the easier it will become. Now back to our code. I will copy the material.label command we've got from the code of video 1 to be a child of rigid. I will change its text to be label 1. I will then duplicate the whole rigid section. Now for the second label, I will change its text. We have now one flex with two children. Both children are rigid and each of them have a label as a child. I know it might look a bit complicated at the beginning of the video, but it's just few lines of code. Let's compile and run the app. See that both labels are displayed in a side-by-side layout, or I should say they are aligned horizontally. This is expected since we set axis to horizontal. I will change now the axis to be vertical and we will rerun. Now the labels are on the top of each other or stacked vertically. Now I will comment the whole flex section and draw a button. And like labels, buttons need to be declared outside the event loop. var button widget.clickable. Under event frame event, I will instruct Gio to draw the button by calling material.button. It takes 3 arguments: th, which is the theme, a pointer to the button that we declared outside the loop, and the text we want to display on the button. Run the code. Nothing here. Let's go back and check the code. I didn't add layout to render the button. I will add it now. Run again. The button is taking up the whole window. It expands and retracts when the window is resized to keep taking up the whole window. There are ways to adjust the size of the button, of course. We will see them later. For now, I showed you this to let you know that displaying a button without any restrictions will make it take up the whole window. I will use this characteristic of the buttons in Gio to introduce flexed concepts in the coming section. Now let's use buttons instead of labels. Copy the command to create the button and comment the flex section. Replace each label command by a button command. Declare the 2 buttons. Change the pointer to the button 1 and its text. Same thing with button 2. Delete the previous command.button. Save the file so the layout package will be included back, and rerun the app. The buttons don't take up this time the whole space on this window because they are under rigid, yet they are stretched on the whole width of the window. Now we will change the axis to horizontal. I think you can guess how the buttons will be laid out. Rerun the app. Now you can see it. This time I will introduce flexed. To see the difference between flexed and rigid, I will change the second rigid to flexed. I need to add the weight. 1 means it will take up all the remaining space. Rerun the app. As expected, flexible button that belonged to flexed took up the whole remaining space, while the fixed one under rigid took its normal size. These hold even when we resize the window. Now I will create 2 flexed and set a different weight for each. Change the rigid to flexed as above. Set its weight to 0.7, which means the widget under this flexed will occupy 70% of the window. Change the previous flexed weight from 1 to 0.3, so it will take up 30% of the window. Let's change also the buttons text to show the percentages. Rerun the app. As expected, the buttons expanded by the defined percentages even if we resize the window. Now let's add rigid back to the mix and have a rigid and two flexed. Rerun the app. You can see that rigid's size is fixed while the two flexed keep their weight even while resizing the window. I guess you're asking yourself, what's the usage of all of that? I can mention 2 points in this regard. One, by combining flex, rigid and flexed, we can create dynamic and responsive UIs. We define whether an element should be fixed or adjustable and how it should behave relative to our elements in a container. And two, by combining them, we can define sections in the window to lay out specific widgets, like a header, a footer, a left sidebar for buttons, for example, and so on. Let's take an example now. We have this window and we want to define a header section at the top of the window, a footer section at the bottom of the window, and a section in the middle that will occupy the space between the header and the footer. This middle section, we also want to split it into two sections as shown. Back to the code. Change the last flex to rigid to hold the footer. Change the text so it will show up in the window. Change the text of the first rigid to hold the header. Update the flex of the middle section, change its text to middle, and change its weight to 1 to let it expand into the remaining space between the header and the footer. Change the axis to vertical. Run the application now. As expected, we have two fixed areas, the header and the footer, and a flexible area in the middle. Now let's split the middle area. What we're going to do here is replace material.button by flex that contain two children. I will keep the material.button and the flex layout for now. I will delete it later so you can see what we're replacing. I will add layout.Flexed under flexed by copying the first flex. Change the axis to horizontal. Close the flex. Under the new flexed, I will add two flexed layouts as we did previously. For the first flexed, I will copy the last rigid and then change it to flexed. Change its weight to 0.7 and the widget's text to middle left. Copy and paste the newly created flex to create a second flexible section. Update its weight to 0.3 and its text to middle right. You may have noticed we need to return a layout dimensions whenever we use a widget under rigid or flexed. Here too, we need to return layout.Flex. Delete the return material button we kept from before, and lastly, change the buttons so each widget would have a different button. Declare the missing ones. Run the application. It shows that the header and the footer have fixed sizes, and middle left and middle right sections are flexible and keep their proportions intact. That's it for today. Please subscribe, like, comment, and share. Thank you.